Okay, this is chapter 8.3, analyzing geometric sequences. We just did arithmetic sequences in series. Now we're switching to geometric sequences in series. So we'll find out what the difference between a geometric and an arithmetic is. And the essential question in this chapter section says, how can you recognize a geometric sequence from its graph? Identify geometric sequences is what you will learn, as well as write rules for geometric sequences. And then we're going to find sums of finite geometric series. So let's take a look. Okay, so identifying a geometric sequence or geometric sequences. In a geometric sequence, the ratio, so there's the keyword right there, the ratio. Let me get my highlighter. The ratio of any term of the previous term is constant. The constant ratio is called the common ratio and is denoted by R. Okay, so let's take a look at that. Ratios. So what are we doing? We're dividing. All right, so example 1, identifying geometric sequences. So when we did arithmetic sequences, we found a common difference, D. We'd say 12 minus 6 is 6. So the common difference between these two is 6. 20 minus 12 is 8. Whoops, 6 doesn't equal 8. This is not arithmetic. But if we take the second term, a sub 2, and find a ratio with the first term, and we get a value, that's going to become 12, a sub 2, divided by the first term, a sub 1, 6, and 12 divided by 6 is 2. Okay, so this equals R if they're all the same. So then I'm going to say a sub 3 divided by a sub 2 equals third term 20, second term 12. Okay, and 20 divided by 12 reduces, that's to 10 over 6. 10 over 6 reduces to 5 over 3. And I'm going to erase this R now because they're not equal. Okay, and then I'm going to take a sub 4 and I'm going to divide it by a sub 3. So 4 is 30. A sub 3 is 20. The zeros cancel. That reduces to 3 halves. And then finally, a sub 5 divided by a sub 4 equals 5, which fifth term, which is 42, divided by the fourth term, which was 30. That reduces to 21 over 15. And 3 will go into both of those. That'd be 7/5. 7 times 6, 5 times 6. There we go. So we got 2 5/3, 3 halves, 7/5. There is no common ratio R. Therefore, this is not a geometric sequence. Okay, they are not constant. So really, all you have to do to determine if one is not is to find one that is different than the other. So I could have stopped right there after 2. Now let's take a look at B. So a sub 2 over a sub 1 equals 64 divided by 256. Okay, well, 64 is a factor of 256. 64 times 2 is 128. 64 times 4 is 256. So it's 1 over 4. Then I do a sub 3 divided by a sub 2. Well, that is 16 over 64. And lo and behold, 16 times 4 is 64. So that's 1/4 again. So far, this looks like it's a geometric series. So then I'm going to check another one. You got to keep going and check them all until you find a difference to determine it's not. To determine it is, you have to check every one. Next one is going to be a sub 4. Fourth term is 4. Third term is 16. And 4 goes into 4 once. 4 goes into 16 4 times. It's a quarter again. And then finally, a sub 5 divided by a sub 4 equals the fifth term 1 over the fourth term 4. 1/4, 1/4, 1/4, 1/4, common ratio of a quarter. This is a geometric sequence. Okay, so that's how you determine if they are or are not. So now you should be able to do problem numbers 6, 8, and 10 in your exercises. Okay, so writing rules for geometric sequences. We have a core concept here before we continue, and it's the rule for geometric sequence, algebra. The nth term of a geometric sequence with a first term, a sub 1, and a common ratio r is given by a sub n equals a sub 1 times r to the power of n minus 1. Okay? Example, the nth term of a geometric sequence with a first term of 2, a sub 1, that goes right here, and a common ratio of 3 given by, so here's my common ratio 3, and it goes there. So it's 2 times 3 to the power of n minus 1. Okay. Looks very similar to an exponential function that we just been dealing with in the previous chapters. All right, so there is the core concept for geometric sequences. So let's take a look at some examples. Okay, so here's the example, writing a rule for the nth term. It says to write a rule for the nth term of each sequence, then find a sub 8. Okay, so we want to find the 8th term after we find a rule. Okay, so just looking at this, I know a sub 1, my first term, is 5. R, my common ratio, is a sub 2 divided by a sub 1. And that's going to be 3. Okay, 45 divided by 15 is 3. 135 divided by 45 is 3. And my common ratio is 3. So then I use my formula, a sub n equals a sub 1 times r to the n minus 1. Substitute in, so it's a sub n equals a sub 1 times r to the n minus 1. So there's my rule. So the rule is a sub n equals 5 times 3 to the n minus 1. And now that I have my rule, I can substitute in my n being a sub 8. So now I want to find a sub 8, and that's going to equal 5 times 3 to the 8 minus 1. So I'm plugging in 8 for n. So a sub 8 equals 5 times 3 to the 8 minus 1, which is 7. So if I get my calculator out, I want to know what 3 to the 7th power is. So 3 to the 7th power is 2,187. Okay, so a sub 8 equals 5 times 2,187. So a sub 8 equals 5 times 7 is 35, carry the 3, 40 plus 3 is 43, carry a 4, 5 times 1 is 5, plus 4 is 9, 5 times 2 is 10, 10,935, or I could have just done this and gotten the same amount. So the 8th term is 10,935. Okay, my rule was right here. So here's the rule, here's the a sub 8. Okay, so that's all you do. So let's try it one more time. A sub 1, so list what you were given. A sub 1 is 88. R equals the second term divided by the first term, which equals a negative 1/2. 44 is half of 88. So there's my a sub 1, there's my r. So now I can write a rule. A sub n equals my first term, 88, times negative 1/2 to the power of n minus 1. So this is my rule. Okay, and now I'm going to substitute in my 8. A sub 8 is going to equal 88 times negative 1/2 to the power of 8 minus 1. So a sub 8 is going to be 88 to the negative 1/2, 7. So then I want to take negative 1/2 to the power of 7. Parentheses, negative 1 divide 2, close parentheses, to the power of 7 is this. And if I hit math, enter, enter, negative 1 over 128. So a sub 8 equals 88 times negative 1 over, what was it? 128. Okay, so then I could just use my calculator now and just say times 88 and get negative 11/16. So a sub 8 is negative 11/16. So there's my 8th term taken from the formula we found, or a rule we found for these values. Okay, so that's how you find a rule and a particular term in the sequence. Now you should do problem number 16 and 18 in your exercises. Okay, example 3 is writing a rule given a term and a common ratio. This is very similar to the last video I made, which was what, chapter 8.2, but it's series instead of sequences, or geometric instead of arithmetic, actually. One term of a geometric sequence is a sub 4 equals 12. Okay, so there's the first thing they're telling us. The 4th term is 12, and the common ratio r equals 2. Write a rule for the nth term, then graph the first 6 terms of the sequence. Okay, so here's what we're going to do. A sub n equals a sub 1 times r to the n minus 1. So first off, write the formula. Next, substitute your givens. We're given a sub 4 equals a sub 1 times r to the 4 minus 1. Okay, so there it is. And then I simplify. So a sub 4 equals a sub 1 to the 2, or times 2 to the 4 minus 1, which is 3. A sub 4 equals a sub 1 times 8. Okay, now I'm going to substitute in my a sub 4, which is 12. So 12 equals a sub 1 times 8. So I'm going to divide both sides by 8, and I get a sub 1 equals 3/2. Okay, so there's my first term. So I'm going to do a table. First term, 1. First term, a sub n is 3/2 or 1.5. Second term, so what are we doing here? We're plugging in our value n. So up here, we're going to put a 2 here and a 2 here with our common ratio. Okay, so first off, we wrote a rule. So a sub 1 is 1.5 or 3/2. And I guess I didn't write the rule yet. So before I go any further, I should write a sub n equals a sub 1 times r to the n minus 1. But I now know my first term is 1.5 and my r is 2. So a sub n equals 1.5 times 2 to the n minus 1. Okay, so this is what we're substituting in. If I put a 1 here, 1 minus 1 is 0. 2 to the 0 is 1. 1 times 1.5 is 1.5. Now when I plug 2 in, 2 minus 1 is 1. 2 to the first power is just simply 2. 1.5 times 2 is 3. Third term, 3 minus 1 is 2. 2 squared is 4. 1.5 times 4 is 6. Okay, and then plug in a 4. 4 minus 1 is 3. 2 to the third is 8. 8 times 1.5 is 12. And now you see what's happening. 5 minus 1 is 4. 2 to the fourth power is 2 times 2 is 4 times 2 is 8 times 2 is 16. 1.5 of 16 is 16 plus 8 or 24. And then finally, the 6th term. 6 minus 1 is 5. 2 to the 5th is going to be 32, I believe. 1.5 of 32 is 32 plus 16 or 48. Okay, so what's happening here? It's getting doubled. 1.5 became 3. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24, 48, and so on. So as n increases by 1, a sub n is increasing by double. Okay, now I'm going to graph that. So go over 1, go up 1.5. Well, here's 5. 5 is here. 2.5, 1.5 is, let's see, 2, 4, 6, 8, 10. Here's 2, so 1.5 would be about here. Go over 2 up 3. 3 would be here, roughly. Go over to 6, or I'm sorry, 3, and go up to 6. Here's 5, 6 would be about here. 2, 4, 6, 8, 10. Yeah, this is in 2s. 2, 4, 6, 8, 10. Here's 6. Okay, go over to 4 and up to 12, which is here. 5, 24, and finally 6, 42, 4, 6, 8. So as you can see, this is curving and going up because it's an exponential function. Okay, we have an exponent, a variable exponent. So it's exponential growth. So there's the graph. Okay, so we wrote the rule, a sub n equals 1.5 times 2 to the n minus 1. We graphed the first 6 terms of the sequence. Now you should be able to do problem numbers 24 and 28 in your exercises. Okay, example 4 is writing a rule given 2 terms. So here we go. So 2 terms of a geometric sequence are a sub 2 is 12. There's the first one they gave us. A sub 2 is 12. And a sub 5 is negative 107 or negative 768. Write a rule for the nth term. Okay, so I don't know, I'll use blue. So first of all, I want to write the general rule, a sub n equals a sub 1 times r to the n minus 1. Substitute in for 2 and 5. So a sub 2 equals a sub 1 times r to the 2 minus 1. So in other words, a sub 2 equals a sub 1 times r. Okay, and finally, a sub 2 is 12, so 12 equals a sub 1 times r. All right, so now we're going to do that again. A sub n equals the first term times r to the n minus 1. Our n is 5 this time, so a sub 5 equals a sub 1 times r to the 5 minus 1. And a sub 5 is then going to equal a sub 1 times r to the 4. And now a sub 5 is negative 100, or negative, I keep saying 1, I don't know why, negative 768 equals a sub 1 times r to the 4. Okay, so there's our 2 equations. So the first thing we're going to do after we do that is we're going to solve this one, the first term, for a sub 1. So I'm going to now divide by r on both sides. So these will cancel, and I get a sub 1 equals 12 divided by r. Now I'm going to take this a sub 1, that is 12 over r, and bring it over, and I'm going to substitute it in for a sub 1 right here. So this is going to be negative 768 equals 12 divided by r times r to the 4th. Think of that as over 1. And this is very similar to what we did a couple of chapters ago. Okay, and then what we're going to do is we're going to cancel an r, and that 4 is going to become a 3. So negative 768 equals 12 r cubed. Now I've got it down to one variable, and I can solve for r by dividing by 12, dividing by 12. And these 12s cancel, and I get r cubed equals, I'm going to get my calculator out and clear, negative 768 divide 12, enter, is negative 64. And now I want to take the cube root of both sides to find r. Cube root of both sides, that will give me r equals. And if I go back to my calculator and take, whoops, clear. Second math, that's right. Nope, clear. math, cube root is 4, and I want negative 64 under the radical, and I get negative 4. Okay, so negative 4. So I found r. R is negative 4. Fantastic. So then what do I do? What are we trying to do? Use two terms of geometric sequence, write a rule for the nth term. So now I'm going to write the rule. A sub n equals a sub 1 times negative 4 to the n minus 1. So there's my rule. Okay. And my first term was, okay, I'm not quite done yet. So actually I shouldn't have done that yet. Let me just erase this a sub 1. I can find a sub 1 by plugging r in over here now. Okay, so a sub 1 is going to equal 12 divided by this negative 4, which equals negative 3. So my rule is going to be negative 3 times negative 4 to the n minus 1. Okay, so there is the rule. And that's a little tricky. What did we do? Let's recap. Write the general formula, substituting in our a sub 2 and our a sub 5, solving the first one for a sub 1, plugging that into the second function for a sub 1 to get it into terms of r, solve for r, and substitute r back into the a sub 1 formula, and boom, we have the first term, r, and our rule. Now you should be able to do problem numbers 34 and 40 in the exercises. Okay, so finding sums of finite geometric series. This is very similar to the last chapter section. The expression formed by adding the terms of a geometric sequence is called a geometric series. The sum of the first n terms of a geometric series is denoted by s sub n. So you can develop a rule for that as follows. So s sub n is the first term plus the first term times r plus the first term times r squared plus the first term times r cubed plus the first term times r to the n minus 1, and so on and so on and so on. And then if I take negative r times s sub n, I get this. So actually trying to come up with, how did they do this? Well, they wanted r's to cancel. So a sub 1 r minus a sub 1 r is going to give me plus 0, plus 0, plus 0, plus 0, plus 0. And then we're going to be left with that minus a sub 1 r to the n at the end. So it comes out to be the series is s sub n equals 1 minus r, 1 minus the common ratio, which equals a sub 1 times 1 minus r to the n, where r cannot equal 1 because you can't have s sub n times 0, you get nothing. So you can divide each side of the equation by 1 minus r to obtain the following rule. So to get s sub n by itself, the sum of the first n terms of a geometric series with a common ratio r not equal to 1 is s sub n is the first term times 1 minus r to the n divided by 1 minus r. Okay, that one's a little bit more complex to explain, so let's just look at the rule and use that in the next examples. Okay, here's example 5, finding the sum of a geometric series. Find the sum of 4 times 3 to the k minus 1 from k equals 1 to 10. Okay, well, if I go all the way back to, where is it? Right here. This is what we're using. So a sub n is a sub 1, the first term, times our common ratio to the power of n minus 1. Okay, so now let me go back to here. So what does that mean? A sub 1 is 4. And r equals 3. Because it's a sub 1 times r to the n minus 1. That's the formula. So our first term is right here, and our common ratio is 3. So a sub 1 equals 4, r equals 3. That's the first thing we want to do. And then we want to use our new formula here and figure out what the sum of this series is. So s sub n, well, n is the number of terms from 1 to 10, and that's 10. So n is 10, and a sub 1 is 4 times 1 minus r is 3, n is 10, all over 1 minus r, which is still 3. So there it is. Substitute our givens and simplify. And 3 to the 10th power is going to be a big number. 1 minus 3 to the 10th on clear 3 to the power of 10 is 59,049. All divided by 1 minus 3, which is negative 2. So S sub 10 equals 4 times 1 minus 59,049 is negative 59,048, all over negative 2. S sub 10 equals, okay, and I can cancel this 4 with this 2 and get negative 2 times negative 59,048, okay, and then S sub 10 equals, a negative times a negative is positive, and we're just going to double this. 8 times 2 is 16, carry the 1, 4 times 2 is 8, plus 1 is 9, 2 times 0 is 0, 9 times 2 is 18, carry the 1, 5 times 2 is 10, plus 1 is 11. So my answer is, oops, parentheses in the wrong place. My answer is 118,096. Whew, that's a big number. So the sum of that series, meaning plug in 1, plug in 2, plug in 3, all the way up to 10 and add them all up, the sum is 118,096. All right, so now you should be able to do problem numbers 48 and 52 in your exercises. Okay, example 6 is solving a real life problem. And I have this real life problem right now. I have a vehicle payment. You can calculate the monthly payment M in dollars for a loan using the formula M equals this, okay? So for starters, it says where L, which is right here, is the loan amount in dollars. I is the, right there, monthly interest rate. Okay, keyword here is monthly. And T, which is up here, is the terms in months. Okay, so we need to be really careful here. Let me switch back to my pen. Let's see, what did I use? Green, L. So L equals. So L is the loan amount in dollars. So we want to calculate the monthly payment on a 5-year loan for $20,000. So there's my L, $20,000. I is the monthly interest rate, and this says annual interest rate of 6%. So my interest rate is going to be 0.00, whoops, I'm sorry, not 0.00, it's 0.06 divided by, so notice this says monthly interest rate and this says annual, so we have to switch it to a monthly rate, which is dividing by 12. So 0.06 divided by 12 is 0.005. And 6 divided by 12 is a half, moving the decimal place 1. So 0.06 divided by 12 is 0.005. Okay, so there's our I. Really careful. Annual interest rate of 6%. Monthly interest rate is that divided by 12, which is 0.005. Anyway, moving along. T. T stands for term in months. I thought it stood for trouble, but in this case, it's terms in months. So how many terms, how many monthly terms are there in a 5-year loan? Well, it's 5 times 12, which is 60. Okay, so L is 20,000, I is 0.005, and T equals 60. So now let's take a look at this formula where it is M equals, and I'm going to draw a line here and substitute in my givens. L is 20,000. Okay, so far so good. This is pretty simple. And then we do our summation. The hardest part is drawing this summation thingy, sigma, capital sigma, and T is 60. So that goes here. And I'm going to start at the first month. So K equals 1, where K is months. And this is going to be times the sum 1 over 1 plus I to the power of K. Okay, so notice down below here, this is a geometric series. It's the sum from 1 to 60 of something to a power. So that's a geometric series. And if I plug in 1 here, I get 1 over 1 plus I. So I'm just going to do a sidebar here. And in my geometric series, I have a first term, which is a sub 1, which is when k is 1. Well, 1 divided by 1 plus I to the power of 1 is just simply 1 over 1 plus I. Okay? Well, what is I? That's the next question. So let me change that right here. I can leave it and then just calculate it. Okay, so a sub I is going to be 1 over 1 plus, and my I is 0.005. So my first term is going to be 1 over 1.005. Hopefully that makes sense to you. So my first term is that. Well, my common ratio is what's in the parentheses. So my R is also 1 over 1.005. So my first term is that, and my common ratio is 1 over 1.005. So what I'm going to do is I'm going to use my calculator. Okay. And I'm going to calculate this for R. So I'm going to say 1 divided by 1.005, enter. And I got 99.99502487756, blah, blah, blah. I'm going to store that value for R and use the letter R right here. It's green, so I go alpha, and the times button is my R. So I'm storing that for R. We've done store before. So now the calculator knows that R is this value and it's not rounding, which is more accurate. Okay. Now I'm going to go back to here, and S sub n, if you will, is now going to become what we're entering in our calculator. So S sub n is going to equal A sub 1, which is 1 over 1.005 times 1 minus R to the n over 1 minus R. Well, 1.005 is R. So I'm going to just erase this here instead of putting A sub 1, and I'm going to substitute in for R. A sub 1 equals R in this situation, so I replace it there. And I already know in my calculator what R is. Okay, so it's R. Here's an R. Here's an R. And what is my N? Well, it's the number of months. So in our situation, our N is 60. So we're looking for the sum of 60 monthly payments, which will become R times 1 minus R to the 60 over 1 minus R. Okay. So there's what we're going to plug in the calculator. So we're going to find how much our monthly payments are. So actually, I'm going to find the sum first, and then I'm going to, well, let's just take a look. Okay, so now I'm going to clear my screen. Remember, R is stored. So I'm going to say R. Okay, so it's going to be alpha R. Here's my R, parentheses, another parentheses for my numerator, 1 minus R, close those parentheses. That's to the power of 60. And then close, whoops, delete, get out of the exponent, close those parentheses. So there's my R times my numerator. And I'm going to hit enter here so I don't mess this up. Actually, I think this will work anyway. So then I'm going to divide by, let's just divide, and we're going to divide by 1 minus R, and that has to be in parentheses. Okay, so we had R, which isn't showing now, times 1 minus R to the 60 divided by 1 minus R, and hit enter. And I got 0. Why? Let's try that again. Alpha R, parentheses. Okay, 1 minus r alpha x to the 60. I'm going to stop right here and just put that in my calculator and hit enter. Interesting. Oh, I know what I'm doing wrong. Okay, I get it. My 60 should be just on the r, not on the 1 minus r. That's why I'm getting 0. So I'm going to do alpha r parentheses 1 minus alpha r to the power of 60, not outside the parentheses. I just want to take r to the 60th power, not the difference. That's why I was getting 0. Okay, so I have that. And then I'm going to divide by parentheses 1 minus alpha r, close parentheses, enter. And I got 51.72556.075. So I want to take, that's my denominator, remember? So then I take my numerator, which is my loan amount, $20,000, divide, and so I don't round this, I'm going to hit second ANS to bring that answer of 51.7255. And I hit enter, and I get $386.66. So $386.66 is going to be my monthly payment. If I didn't divide that, or if I now multiply that by 20,000, or how many months there are, which is 60, if I multiply that by 60 now, it's $23,199.36. So the sum of all those payments is $3,199 more than what we borrowed, and that's your interest. Okay? But what this question was asking is calculate your monthly payment, and it is $386.66. Okay, hopefully you understood that. It's a bit of a challenging problem, but there you have it. So now you should be able to do problem number 57 if you understood that. Okay, so that brings us to the end of chapter 8.3. Here are the exercises that I assigned my class. Thanks for watching, and have a great day.